Assalamu alaikum warahmatullahi wabarakatuh. Today we are going to study lesson number 6 from unit 4. It's all about adding more than two-digit numbers. It's all the way from page number 157 to page 160. First of all, there's a problem here. We need to add three two-digit numbers. That's 12 plus 34 plus 29. We need to find how much are these three two-digit numbers. What's the sum of these three two-digit numbers? Tom says he can find the sums by adding 28 and 12 first. That means he's saying that he won't be adding all the three two-digit numbers together. Instead, he will be adding two of them first. He says he can add 34 to that sum to find that total. That means he will be adding 12 to 28, and once he gets the sum of these two numbers, he will be adding the third number, that's 34, to that sum to get his final total. Do you agree? Use pictures, words and numbers to make a math argument. That means you have to show how he can do that. You can use the pictures, you can use the words or the numbers. Then solve the problem and show your work. Let's see how we can do that. Here we know that he will be adding 28 plus 12 first. That means these two numbers. And why he thought of adding these two numbers first? Because when we look at the numbers at the ones place, we see that they are making a 10. 8 plus 2 makes a 10. So that's why he has chosen these two numbers first to add them. Let's add them in the partial addition method. So I'll be copying 12 here and 28 here. So I know 1 and 2 in the tens place makes 10 and 20, that equals to 30, and 2 and 8 together they are in ones place, so they are 10. 30 and 10 makes 40. That means the first sum of these two numbers is 40. Now I need to add 34 to this number 40. Let's see. Here I have taken the 40 and I have written here, and I have taken 34 from here and I have written here. Now I'll be adding the same way I did in the first step, the partial addition method. I have added 4 and 3 in the tens place. That means 40 plus 30 equals 70, and 0 and 4, that makes a 4. Now finally I'll add these partial sums. 70 plus 4 equals 74. That means the total sum of these three two-digit numbers is 74. I can solve the same equation by using another strategy, and this time I'll be using the models or my lines and dots to show the tens and the ones. Again, I have represented here, I have shown 12 like this, a 10 and 2, 34 like 3 tens and 4 ones, and 28 by 2 tens and 8 ones. Again, I see here, if I go and add these two together, I can see 2 in the ones place and 8 in the ones place. That means if I take these two and I move them here, I can easily make a 10. So that's why I'll be adding these two together. I'll move these two ones to make a complete 10. Like this, I can move these two and I have got 10 ones. I can regroup them, and now these 10 ones can be replaced by a single 10 like this. Now I have got how many tens? 1, 2, 3, 4, 5, 6, 7 tens and 4 ones. That means my answer is 74. Now in this lesson we are going to see some more ways to add more than two-digit numbers, and let's have a closer look at that. Here we have got an equation, 24 plus 35 plus 16 plus 17. That means we have two-digit numbers that are not 2 but more than 2. We have got 4 two-digit numbers. Now there are many ways to show how we can add these. The first way is again by showing the models, but this time we are not showing the models for two numbers. We are going to show them for all three or four two-digit numbers. Like here 24, we can see 20 and 4. 35, 30 and 5. 16 is shown by 1 and 6 dots. And 17 is shown by 1 and 7 dots. Finally, you can add the whole tens together like this. 1, 2, 3, 4, 5, 6, 7. 7 tens means 70. And then when we add these all ones together, they end up to having 22. And 22 means if we split it into tens and ones, it makes 20 and 2. So it's so easy to add 70 and 20 to makes 9. It makes 90, and then add a 2 that makes 92. So this is one way using the models or the lines and the dots. The other way is by partial sums. The similar way we used to have in a previous lesson, we used to add just two-digit numbers. This time we'll be adding more than two, that is here 4 two-digit numbers. We will be writing them each under each other like this, tens in a line and ones in a line. Then we will be adding the tens first here, 2, 3, 4, 5, 6, 7. So there are in all 7 ones, that means 70. Then we'll be adding the ones together, and when we add them, they end up to be 22. The sum is 22 for these ones. Finally, we add the partial sums, the 70 and 22. So 0 and 2 equals 2, 7 and 2 makes 9. So this is the other way to add more than two-digit numbers. There is another way of adding the numbers. It is by adding again partially, like we can add two of the two-digit numbers first and two in the other step, and finally once we get the sum for each of these two, we can add them together. Like here we have seen they have added two-digit numbers and they have got an answer here. Again here they have grouped and added these two-digit numbers, they have got their sum here. Finally they will be adding this and this together to get a final sum. But there is another important thing to see here. If we look at this equation very carefully, it's 24 plus 35 plus 16 plus 17. But here we don't see after 24, we don't see 35. It's moved to this side. Instead, they have brought 16 here. And why it happened like that? To understand this, we need to understand the commutative property of addition. Let's see what's the commutative property of addition. First of all, practice reading this word with me. Commutative property. Commutative property. And what's a commutative property? It's that if we change the order of addends, just like we studied in the first lesson, the sum remains same. So it doesn't matter if I make 5 plus 2 or I make 2 plus 5. Either way, I'll be having a sum of 7. This is called the commutative property. That means the order of addends, no matter how much you change, the final sum will remain the same. Here we have got another example. We have got more than 2 addends. We have got 3 addends. One is 4, the other is 3, and the third one is 1. So we're adding them, and I can show them with the help of dots here. 4, 3 and 1. So let's count 1, 2, 3, 4, 5, 6, 7, 8. So that means 4 plus 3 plus 1 equals 8. In this second example here, I have changed the order of addends. 3 has come here, 1 here and 4 here. Now the order of addend is different, but still we see 1, 2, 3 for the 3, 1 and 4 here. Let's count them together. 1, 2, 3, 4, 5, 6, 7, 8. Again, I have the sum of 8. In the third example, again I have changed the order of addends. This time I have 1 first, then 3, then 4. I can show them with the dots, and again let's count them together. 1, 2, 3, 4, 5, 6, 7, 8. Again I have got a sum of 8. That means no matter how much you change the order of addends, the sum remains same. So it's no problem changing the order of addends. So if you want to change the order of addends that will help you to solve the equation, it's okay to do that. Once we have understood the commutative property of addition, let's have again a closer look at this equation. 24 plus 35 plus 16 plus 17. Here we see they have changed the order of addends. Instead of 24 plus 35, they have 24 plus 16. They have moved the 16 after 24. Let's have a closer look at this. Now here I have copied the same equation, 24 plus 35 plus 16 plus 17. I can see by looking at their ones place that here we have got a 4 and here I have got a 16. That means 6 and 4 in the ones place, they will add up to have a 10. So I'll better add these two first. So I'll be taking 24 first and next to it I'll write 16. Then later I'll be adding 35 to 17. So I'm going to cover this because right now I don't need it. I'll just copy 24 here and 16 and I'll go adding them up like 20 and 10 it makes 30 and 4 and 6 make a 10. Now I'll be adding 30 to 10 and the final sum is 40. So this is the sum for 24 to 16, 24 plus 16. So by adding 24 to 16, I got the answer 40. Now I'm going to work on this part of the equation, that is 35 plus 17. I'll add them up like this. I'll copy 35 and 17. 30 and 10 makes 40, 5 and 7 makes 12. These are my partial sums. Then I'll add them together. 0 and 2 makes 2 and 4 and 1 makes 5. So my final sum of this step is 52. So I'll copy this 52 here. What I need next is to add 40 to 52. Here I have copied the sum for this 40 over here and the sum for these two 52 over here. Now I'll be adding the tens just like I did in the previous steps, the partial addition method. 4 and 5 in tens place means 40 and 50, and 40 and 50 mixed together 90, and 0 and 2 in the ones place, it goes here. I'll be adding the partial sums together. 90 and 2 makes 22. So I'll be copying the sum for 40 and 52 here. That means the sum of 40 and 52 is 92. Now we have understood very carefully, very closely how this commutative property works. We are moving the addends in the way we like to, but still we get the final same answer. Now here they have asked here, look above, why do you think the order of addends changed? Why do you think 24 and 16 were added together? We have already seen that we have moved this addend next to 24, and why we did that, we now know that because we see here 6 in the ones place and 4 in the ones place, they add up to make a 10. So we can write here we have shifted them because to make a 10, because we know 4 and 6 together make a 10. Let's solve this equation, first one on page number 158, 18 plus 15 plus 12. If I look very closely at these numbers, I can see I have got the ones place 8 and 5 and 2. I can see here 2 and 8 together make a 10. So I'll be adding these two first, 18 and 12. I'll copy this equation like this, 18 plus 12 here. 1 and 1 in tens place makes 2, and that means it's total of 20. 8 and 2 together in the ones place make a total of 10. My partial sums 20 plus 10 make a total of 30. So the final sum 30 for 18 and 12, I'll be copying it here. Next, I'll be adding 30 to 15 to see my final total sum. Here you can see I have copied here 30 and 15. So 3 and 4 in the tens place makes 4, that means 40, and 0 and 5 is 5. Now I'll add the partial sums together. 40 and 5 makes 45. So the final sum for 30 and 15 will be 45. Now let's come and solve the second equation on page number 158. It's 11 plus 14 plus 39. Firstly, we'll have a closer look at their ones place. I can see here 1 and here 4 and here 9. That means if I do these two first, 1 and 9, they make a 10. So I'll be adding 11 and 39 first. So I can write this equation like this. I'll be doing 11 and 39 first, and then to the sum of these two numbers, I'll be adding 14 later. So I'll copy this equation here like this, 11 plus 39. Now I'll add them. 1 and 3 in tens place makes 4, that means 40, and 1 and 9 in ones place make 10. I'll add the partial sums. 40 plus 10 equals 50. So I've got a total sum of 50 that I'll copy here. That means the sum of 11 and 39 is 50. Now I have got the sum of 11 plus 39 equals 50. In next step, I'll be adding the remaining 14 to the sum of these two numbers, 50 plus 14. So I can copy this equation like this: 50 plus 14. 5 and 1 in the tens place makes 60, and 4 and 0 makes 4. So 60 and 4 together makes a total of 64. My sum is 64, and I can copy this final sum here. 50 plus 14 equals to 64. This is how I do the addition of two-digit numbers in two steps. I can replace or do any two addends first, and to the sum of those two addends I will be adding the third one. Now let's have a closer look at the next problem on page number 158. Here we do not have three two-digit numbers. Instead, we have four two-digit numbers. Now, up till now, we had been doing like adding two-digit numbers together, and to the sum of that, we were adding the third one. There's another way to add the two-digit numbers together, and this is here like partial sums, but this time we won't be adding just two-digit numbers. We can add all 3, 4, or as many as we want to in the same way we did here. So I can copy this equation: 21 plus 14 plus 41 plus 22 like this. Here, 21, 14, 41, 22. Now, all I need to do is add all the tens first together, like here 2 and 1, 3, 3 and 4 makes 7, 7 and 2 makes 9, and 9 in tens place means 90. So I'll be writing here 90. Then I'll be adding the ones in the second step, like here 1 and 4 makes 5, 5 and 1 makes 6, 6 and 2, 8. So the sum of the ones place is 8. So I'll be writing 90 and 8 here, and I'll be adding them together to my final sums, 98. So instead of adding them in two different steps, I can add them all together using the partial addition method, and my sum here is 98. Let's solve the final sum on page 158, 21 plus 15 plus 32 plus 25. Again, we have two-digit numbers more than 2 or more than 3. We have got four two-digit numbers. So I can copy the equation in the same way I did in the previous equation. Here 21 plus 15 plus 32 plus 25. All I need to do now is add all the tens first. 2 and 1 makes 3, 3 and 3 together 6, 6 and 2 makes 8, and 8, if it's in the tens place, that means it's 80. Now let's add together the ones place. I can see here 5 and 5, that makes 10. So I'll add the 5 and 5 together first. 10 and 2 makes 12, and 1 makes 13. So the total of the ones place is 13. Now I'll add the partial sums together. 0 and 3 equals 3, and 8 and 1 equals 9. 3, 3. So my sum is 93, and I'll be copying it over here like this. Now we are on page 159. The sums above are just like the same we have solved in the previous page. So these can be solved on their own. Here down we have got a little different sort of sums. Let's see how we can do them. Here number 11 is 8 plus 3 plus something plus 2 equals 18. That means we have four addends and one of the addend is missing. We know that the amount is always same on both sides of the equals. So if it's 18 on this side, the numbers should be adding up together to make an 18 here too. So what we can do is we can add the addends, whatever the numbers we are having right now, and see what's the missing number. So 8 plus 3 is 9, 10, 11. Then I'll add 2 more to 11, that's 12 and 13. That means my total up of these three numbers is 13. I know that here it's 18, so I need to find this missing addend. I'll be counting after 13 until I reach 18, and I'll see how many numbers I have got. So after 13, 14, 15, 16, 17, 18. 5. That means 5 is the missing number here. So that means if I add 5 to 13, I'll get a total of 18. This way, I'll be having the same amount on the both side of equals. Here 18 and here if I add them together all, you can check them all together by adding them again. They are total, the sum will be 18. Similarly, we can do the same equation number 12 on the same page. We will be adding the given addends together to get our initial sum. So 5 and 5 together make a 10, and I'll add 6 to that. 10 and 6 makes 16. So the sum of the addends available here is 16, but the total sum should be 19. So I'll be counting after 16 until I reach 19. So after 16, I have got 17, 18, 19. That means the missing addend is 3. I have got 3. If I add 3 to 16, I'll get the total of 19. This way, the both sides of equal will be the same. Now let's see the equation, the problem number 13 here. Here we have more than 3 addends. Similarly, here we had 4 addends. Here again we have 4 addends, but this time some of our addends are 2-digit numbers. Now they are not single-digit numbers, so it's a little more tricky to add the 2-digit numbers. So instead of adding them orally, I'll be copying them in the form of a partial addition way. Here I have copied 7, then 27, then 23 to find the missing addend. Let's add these addends. So 2 and 2 in the tens place makes 40. That's 4, and that means 40. And I'll add these in the ones place, 7 and 7, that's a doubles fact, that's 14. Then 15, 16, 17. That means the sum of the ones place is 17. Now I'll add my partial sums, 40 and 17. 0 and 7 makes 7. 4 and 1 makes 5. So that means the sum of these addends is 57, but the total sum should be 61. So I'll be counting after 57 until I reach 61. So let's count after 57. 58, 59, 60, 61. I have counted 4 more steps to reach to 61. That means the missing number here is 4. Let's solve the final sum on page number 159. Again, here we have got 4 addends. One of them is missing, and the 2 of these addends are 2-digit numbers. So it's better we will be writing them in the form of this partial addition way: 24 and 18 and 4. See clearly, when there is only one digit here, we should be copying in the ones place. So now I can add 2 and 1 together, and they add up to have a 30. And 4 and 4 in the ones place, this is the doubles fact. 4 and 4 makes an 8. And once again, I have got the sum of 4 and 4. It's 8. Again, doubles fact 8 and 8 together makes a 16. I'll be adding them together. 3 and 1 makes 4, and 0 and 6 makes 6. So that means the sum of these 3 addends is 46. That means I need to add something more to this 46 to get to 52. I want to count, now I need to count after 46 until I reach 52. I can do this counting by using my fingers, or I can draw the dots to count how many more I need to go until I reach 52. So let's count after 46, 47, 48, 49, 50, 51, 52. I have reached 52. How many did I count? 1, 2, 3, 4, 5, 6. That means my missing number is 6 here. On page number 160, we have got some word problems. Let's study them one by one. 28 trucks are blue. Here we can see 28 blue trucks. 32 trucks are yellow. Means here we can see 32 trucks yellow, 17 trucks are green, and 11 trucks are pink. How many trucks are there in all? We have got 4 addends, each of them is 2-digit number, so I can easily write it in the form of a partial addition way. 28, 32, 17 and 11. I'll be adding the tens first. 2 plus 3 makes 5 and 6 and 7, so that means it's a 70 here. Then I'll add the ones place. 8 and 2 makes 10 and 10 and 7 makes 17 and 1 18. That means here I'll write 18. Now I'll add the partial sums. 0 and 8 makes 8, 7 and 1 makes 88, so my total is 88. Next we have got another sum. Jewel won 19 tickets in March, 24 tickets in April, 23 tickets in May, and 16 tickets in June. How many tickets does Jewel have in all? She has won some tickets from all along from the March, April, May, June. Each month there is a different number of tickets she won. Now we need to add all these 4 addends. Each of them is a 2-digit number, so I can easily write it in the form of partial addition method. 19, 24, 23, 16. I'll add up the tens here. 2 and 2, 4 and 1 and 1, 4 and 1, 5 and 1, 6, 60. And I'll add the ones together and I'll find that it's a total of 22. I'll add the partial sums together. 0 and 2 makes 2, 6 and 2 makes 8. So the total of these all number of tickets, now she has got 82 tickets. Let's look at the next problem here. Henry is adding numbers 24, 18 and 36. He makes a 10 to add. That means we have to add any 2 numbers first. That will make a 10. Which one's digits does Henry add first? Explain. Now let's have a closer look at these 3 addends. I can see 4 in the ones place here and 8 in the ones place and 6 in the ones place here. I can see if I add these 2 addends first, like 6 and 4, I can make a 10. So I'll be adding these 2 addends first, like this. 24 plus 36. Now I'll add the tens. 2 and 3 makes 50, 6 and 4 make a 10, 50 and 10 makes a 60. Now I'll add the sum of these 2 addends, that's 60, to the third addend, which is 18, like this. 60 plus 18. So I'll add the tens first. 6 and 1 makes 70 and 0 and 8 makes 8. I'll add the partial sums together. 70 and 8 makes 78. Now how can I explain it? I can write it like this. I added in the first step 24 and 36 like here. Why I added them first? Because I can see in the ones place I have got 6 here and I have got 4 here, and I know that 6 and 4 together they make a 10, so I can add them first quickly, and this way I got a total sum of 60. Then I took this sum and added to the third addend, it's 18, and I got a total sum of 98. Next we come to the final sum here. Find your sum, use any strategy, show your work. Again, we have got 4 addends. Each of them is a 2-digit number, so it's better we'll be adding them in the partial addition method. 25, 16, 15, 38. We will add the tens first. 2 and 1 makes 3 and 4, 5, 6, 7. That means it's 70. And I'll add the tens first quickly. It's 5 and 5, 10. And 10 and 5, 10 and 6 makes 16. And I'll add 8 more to 16, 17, 18, 19, 20, 21, 22, 23, 24. I have got a total of 24 for the ones. I'll add the partial sums together. 0 and 4 makes 4. 7 and 2 makes 9. That means my total sum here is 94.